Hello and welcome to lesson 10.1. Today we're going to look at quadratic graphs. There will be two types of graphs that we look at. One is going to be when we have y equals ax squared, and then the next is when we're going to take that same graph of y equals ax squared and we're going to add a constant to it. So to begin with, we have to understand what a quadratic function is. And if you remember back from chapter 9 when we were looking at polynomials, a quadratic function is essentially a second degree polynomial. So what that means is that the largest exponent is going to be a degree of 2. When we look at this is what we call a standard form, the y equals ax squared plus bx plus c. The a portion and the b portion are coefficients of the x and the x squared terms. That just means it's some number. The c is always going to be a constant, which means that will never change. In order for a function to be quadratic, it has to have that x squared term in it. It can't have anything greater than an x squared term, but it has to have an x squared in it. So if we take a look at a few examples of quadratic functions, notice in this first one here, we have y equals 3x squared plus 5x plus 1. If I had to go through and identify, the 3 is really my a value, the b is really going to be my 5, and then my constant, or c, is going to be the 1. And that's, again, looking at the function or the standard form y equals ax squared plus bx plus c. Okay? In the second part, I have -2. This is going to be my a. My b in this case is really equal to a +1 because that's really a 1x. And my c is a -1. Now, in this next example, my a is going to be that 1/3. My b is going to be 9. And then you don't really have a value for c, so you could say that c is equal to 0 if you wanted to list it. And then for the last part here, you can see that your a value is going to equal 1 because that's really 1x squared. You do not have a b value, or if you wanted to, I guess you could put that b is equal to 0. And c here is going to be a -2. But if you notice, all of these functions have an x squared term. Okay, that's what makes them quadratic. When we look at a quadratic function, we have what we call a parent function. A parent function is like y equals x squared. So a parent function is kind of like what all of your graphs should kind of generally resemble, kind of like you resemble your parents, okay? A parent function of y equals x squared is going to be a U-shaped graph. So notice here, I have a nice U shape, okay? Over on the right here, this is a U-shaped graph. It's just an upside down U. So we know that all quadratic functions are going to have some U shape to them, okay? And that's because the parent function is U-shaped. We call this U-shaped graph a parabola, okay? That is something that you are going to have to familiarize yourself with and be able to say, okay? If you notice, parabolas are symmetric. Now in this example here on the left, you can see that the graph is symmetric with the y-axis. So if we were to take this graph and split it in half and fold it over, it would be perfectly symmetrical. If I come over to the graph here on the right side, I can draw a line through x equals -2, and this graph is symmetrical through there. Okay, we'll talk more about symmetry later. Or we'll do it right now. So the axis of symmetry is what we call it. This is going to be that line that separates the parabola into two equal halves. So again, this equation right here is going to be my y-axis, or when x equals 0. In this graph over here, my axis of symmetry is when x equals -2. We also have what we call the vertex. The vertex is either going to be the highest or the lowest point, and it will always fall on the axis of symmetry. So if we look at the graph here on the left, my vertex is at 0, 0. That is the very lowest point on this graph. When I look at my graph here on the right, however, my vertex is going to be the highest point. And the coordinate points for that would be a -2 and a +4. So your vertex and axis of symmetry are very important parts when you are drawing your parabolas. X and Y intercepts are also going to be important. So when we look at example 1 here, it says to identify the vertex of each graph and tell whether it's a maximum or minimum. So if I go and look at this graph here on the left-hand side, my vertex is right here. The coordinate of that vertex is going to be a +1 and a +2. And because my parabola is upside down, this is going to be considered a maximum point. Likewise, on my graph here on the right, I can see that I have my lowest point right here at the coordinate point 2, -4. And because it's at the bottom of that U, then this would be my minimum value. So here in just a second, we're going to start graphing our own quadratic formulas. Okay, for right now, what we are going to do is we are going to make a table and plot some points. This is something you do not have to have a calculator for. Okay, I'm going to show you a couple methods later on, but for today, we're going to start out by making tables and plotting points. Okay, so first I'm going to graph the example of y equals x squared, or this is my parent function. So when I make my table, I'm going to just make an x and y table. Now I personally like to have a few negative numbers, a few positive numbers, and 0. So I like to use -2, -1, 0, 1, and 2. Now what I'm going to do is I'm going to take these numbers and I'm going to plug them into my function or my equation, y equals x squared. So for this first one, I have y equals a -2 squared. Well, a -2 times a -2 is going to give me a +4. If I plug a -1 in, -1 times -1 is going to give me a +1. When I plug 0 in, I get 0. 1 squared will give me 1, and 2 squared will give me 4. So now if you notice, you have all these coordinate points that you can now go ahead and plot. So if we plot these, we end up with something that looks like this. -2, 4 is going to be -2, up 4. I have -1, +1, 0, 0, 1, 1, and 2, +4. So here's all my points. Then what you can do is you can just go ahead and go in and connect those points in a smooth curve and create your quadratic function. And this is all we have to do. Now, one thing I would like to point out, please make sure that you label your x and y axis at least somewhere so I know if you're going by 1s or 2s or 10s. Okay, so make sure you have a correctly labeled x and y axis somewhere. Now we're going to do the same thing for part B of example 2. Again, I'm going to create my table. I have x, y. My graph is going to be of y equals a -x squared. I'm still going to use my points of -2, -1, 0, 1, and 2. When I go to plug in that -2, I have y equals a -2 squared. Well, orders of operations tells me I have to do my exponent first. So a -2 squared is actually going to give me a +4. Then I'm going to multiply that by that negative that I have in the front, so I end up with a -4. Then I'm going to plug in the -1. Well, that's really a -1 squared. So -1 squared is a +1, but I multiply it by a negative, so I end up with a -1. When I plug in 0, I get 0. When I plug in a 1, I'll get a -1. And when I plug in a 2, I'll get a -4. And again, I'm just going to go and plot my points. So once I have my points plotted, you can see that I get kind of the shape of an upside down U now. Now that upside down U is actually going to come from the fact that I have a negative in front of that x squared term. So anytime you have a negative number in front of x squared, know that your graph should be facing downward. If it's a U shape, that tells me that that number in front of x squared is a positive number. And finally, we have example 2, part C. I'm going to graph y equals 4x squared. So again, I'm going to start out, I'm going to make my table and plot my points, just like you see here. I'm going to continue to use -2, -1, 0, 1, and 2. I'm going to plug them in. So if I show you the first point, I have 4 times a -2 squared. Well, -2 squared is 4, so I end up with 4 times 4, which is 16. A -1 squared is 1 times 4, will give me 4, 0, 4, and 16. So now I see that my y values have to go up to 16. So I'm probably going to make each tick mark on the y-axis 4. So I'm going to go 4, this is 8, 12, 16, 20, 24. And then I can continue to make everything on the x-axis by increments of 1. So I have 2, 4, 6, and so on. Then I'm going to go ahead and plot my points. And I get something that looks like this. Now notice, if I go and I connect these, I have my U-shaped parabola, which I would expect because the value in front of my x squared is a positive number. Now some things to remember when you are graphing quadratics. It says if our a value is greater than 1, so this number right here, the graph is going to be narrower. If that value is less than 1, then our graph is going to widen up. And then it tells us here, it says if the sign of A is positive, then we get that U-shaped graph, which is what we just saw. And if this A value is negative, we'll get that upside down U shape. So please kind of keep these things in mind when you're graphing your quadratics, because these are kind of like quick little checks that you can do to make sure that you're on the right track. So now when we look at example 3, all we have to do is look at the coefficient to see which number is going to be the smallest, and that will be the widest. It doesn't matter if it's positive or negative. We just need to go with the smallest numerical value. So in that sense, 1/3 is going to be wider than 3 or -4 or 4 in this case. So that means I'm going to have y equals 1/3 x squared as my widest. The next widest will be 3, because 3 is smaller than 4 if I take the absolute value. So then I have y equals 3x squared, which then leaves me with y equals a -4x squared as the narrowest. Now, as you proceed with your math careers, you're going to see that quadratic applications are going to be used to model the height of a falling object if we ignore air resistance. And the generic formula that you'll see is h equals -16 squared plus c. So h is going to be our height, which is going to be measured in feet. T is our time, and time is going to be measured in seconds. And c is going to be our initial height, okay, or where you're launching that object from. So let's take a look and see how this is going to work. So for example 4, it says, suppose a squirrel is in a tree 24 foot above the ground. She drops an acorn. The graph h equals -16t squared plus 24 gives the height of the acorn in feet after t seconds. We need to make a graph for this function. So just based on looking at the equation alone, even if they didn't tell me that the squirrel was in a tree 24 feet above the ground, because my constant is 24, I know that this is where we're going to start. So in a situation like this, it doesn't make sense to look at negative time values. I only need to look at positive values. I do want to know what's going on at time t equals 0. So when I set my table up, I'm going to start out with time and height, and I'm going to start with a time of t equals 0. When I plug a 0 in for t squared, I can see that that's going to leave me with 24. Then I might do something like 1 second and 2 seconds. When t equals 1, -16 times 1 is a -16 plus 24. That's going to give me 8. If I plug a 2 in for t, I'm going to end up with a -40. So in less than 2 seconds, this object is going to go up and hit the ground. So you may want to come in and do another point, maybe right in here and do something like 1.5 just to give us another data point. When I plug in 1.5, I end up with a negative 12. So now what I'm going to do is I'm going to go ahead and plot these points. Now that I have my points plotted, I'm going to connect them, and you can see that we end up with something that looks like this. Okay, I know it should be going downward because I have this negative 16 in the front. It has kind of that curved shape like a parabola should. And at any point in time along this curve here is where I could find the height of that falling squirrel. For our last example, it says, suppose you can see an eagle flying over a canyon. The eagle is 30 feet above the level of the canyon's edge when it drops the stick from its claw. The force of gravity causes the stick to fall forward. The function is modeled by h equals negative 16t squared plus 30. We want to find a model that will represent this stick falling. So again, I'm going to create my table, my time, and my height. I'm going to start out with a time of 0, a half a second, 1 second, 1.5 seconds, and 2 seconds. I know that my initial height is going to be 30 when I plug in a 0. At a half a second, I have a height of 26 feet. At 1 second, I'll have 14 feet. At 1.5 seconds, we're now down to negative 6 feet. And I know that 2 seconds is going to be in the negative range as well. So I'm going to go ahead and plot these points here. When I plot my points, I get something that looks like this. And now I'm going to go ahead and come in and connect these. And you can see that we get something that looks like that. Please let me know if you guys have any questions. Otherwise, have a great day, and I will see you in class.